Now let's continue on problem 6, in which the answer wasn't looking right. And when I looked at it, guess what? See, it's right here. There is a 30 minus 32 is negative 2.5, right? And I missed the negative, and then the whole thing then, of course, goes to pot. And so now I have to fix it. All right, so let's fix this thing. If m is negative, so there's a negative sign here, negative, okay, and then multiply it out, becomes negative c, then this becomes a plus. If it becomes a plus, then this number is no longer 9. It's 75 plus 84, which is equal to 159, which looks much more like what the book has, right? It says, the book also says something about 159,000. Remember that my numbers here all means 1,000. Okay, so now we have S, which makes life much better. And next, we need to max out C times S. So, which I have written down right here. Okay, C times S is C times negative. This better be negative because the parabola needs to go down so that we can maximize it, okay? If the parabola go up, then the maximum profit is infinity, which is like, how is that possible? You know, something is way off. So this is plus minus 2.5 plus 159. Let's fix that. Plus 159. Okay, so that becomes, again, 159. So this is 159C. Okay, so then the H would be equal to, the H then equals to minus B over 2A. Okay, so minus, this is B, so 159 divided by 2 times, this is a multiplying dot, okay, 2 times 2.5, that is equal to, what's 159 divided by divided by 5? That's 3, 33, and then 1, and then 8, right? Yep, it is. See, your book says the same thing. H equals to 31.8. All right, so that's good anyway. So that's H. What are we looking for? The maximum profit. So we need to figure out what K is, and better not forget this negative sign, right? So H is equal to, minus 31.8. Then K plugging is f of H, or in other words, K is plugging H in this value. This is, let's call this the function of C. All right, because I have C value here. So f of C plugging H as C, we get, so f of 31.8, that will give us the maximum value, is, okay, so 2.5 times 31.8 squared, and then plus 159 times 31.8. 31.8, and that equals to something. Okay, so let me get the calculator and punch this thing out. So I got the wrong answer again, and upon looking at it, guess what? I forgot the negative sign yet again. So once you put in the negative sign, I changed the formula on the calculator. Okay, and then things looked quite a bit better. So I will push the answer, and that equals to 252528. And that is correct. Okay, I got, what was the answer again? 2528.1. So the answer is 2528.1, and the 0.1 will go into the 1,000, because remember my answer is in thousands, so it's 2528,000. 0.1000. 1,000 has 3 zeros, okay, so you move 3 zeros over, so that gives us something like $2.5 million, which is the maximum revenue, okay, and as you can see, that is what the graph did. Now I have in this problem I have taken a shortcut of just writing the numbers as thousands instead of writing out the zeros, which saves a little bit of time, but you do have to remember to make it go back to 1,000. Otherwise, your answer is off by 1,000 times, which is you don't want that. Right? And so if you don't want to make that mistake, you could just write out the extra three zeros every time, and then that's a safer way to doing things. But if you want to do things the lazy way, then you can skip the 1,000 and hope that you don't forget to put it back later. And now let me erase the board. Now, before we move on to the next example, I decided I want to talk about the concepts in this chapter a little bit more. The reason I didn't talk about it before is because the book just kind of went ahead and stated it, so I followed along and didn't give it much thought. But I want to explain why the vertex is minus b over 2a at h. Okay, and so we know what this means. This means when you draw a parabola like this, okay, the vertex, the x-coordinate is equal to minus b over 2a, and then which means the axis of symmetry is x minus b over 2a, and the vertex is located at the x-coordinate is at minus b over 2a. But the question is, why is that? The solution is actually quite straightforward. And what happens is, you remember let's see, quadratic formula, right? Which is the quadratic formula says x equal to minus b plus or minus b squared minus 4ac all over 2a, which I asked you to memorize. And if you haven't done so, or if you have already forgotten it, please do so again. So generally speaking, then the quadratic formula states that x equal to minus b plus or minus something over 2a. Right? And the other one is x equal to minus b minus square root of b squared minus 4ac over 2a. So these are the two roots of any quadratic formula, quadratic equation. Now, to find the middle point, so we have two roots, okay? So if your function goes through this thing at two roots, right? Here are the two, we'll call this one x1 and this one x2, where x1 is over here and x2 is over here. Now being that the parabola is symmetrical, then the midpoint, if you can figure out what the middle point is between x1 and x2, that point is exactly where the vertex x-coordinate would be. See, and that's what we're doing. So what we're doing here is we'll take the midpoint is between the x1 and x2, okay, I'll call it midpoint, then has to be equal to x1 plus x2 divided by 2, their average. So the midpoint would be x1 plus x2 divided by 2, and that value is equal to, let's add these two things together, okay? So that equals to, let's see, and let me think. Right, anyway, so we have then equals to 1/2, okay, the 2 here, then times x1 plus x2, then x1 equals to minus b over 2a, and then so is 2a, and then plus this stuff, I'll call the stuff inside the root, just call it a d, because the other one is minus this stuff, okay? So we just have minus b and minus b. That's it. Because the rest of the stuff, there's a plus and a minus one, and they destroy themselves. So then the whole answer, then it equals to, when you look at this whole thing, then it equals to minus b over 2a, when you cancel out the extra 2 here. So the whole thing then end up being minus b over 2a. So minus b over 2a is the x-coordinate right here. Minus b over 2a, and that's why the coordinate here is minus b over 2a, comma something else, k, right? And we'll calculate k by plugging this into the function of the parabola, and then they'll give us the k. But that's how the minus b over 2a comes about. And I thought I should explain this more carefully so that you have an idea. Okay, so now that I've said that, let's move on to the next example. So next, let's look at problem 7, example 7 on page, this is 411, where we are considering finding the y-intercept and the x-intercepts. So the x-intercepts is where the graph crosses the x-axis, and which means so let's find the x-intercept first. So the graph will be crossing the x-axis. That means this thing, the y value will be 0. Okay, remember f of x is y. So the y value will be 0 when it crosses, and then we have this equation to solve, which we have done before. Okay, many times actually. So we'll do the same trick and hope this works. If it doesn't, then we'll pull out the quadratic formula, which is, as you might remember, is minus b plus or minus b square root of b squared minus 4ac over 2a. Please memorize that. Now this thing, it has to come out, right? So we have, this has to be 3x and x. This is if it works. We have to have plus 5. So if we have say plus 2 and minus 1, that should do it. Yeah, 3 times 2 is 6, right? Minus 1 is 5. So it all works out. And therefore, this is this is equal to 0, which means each part has, one of them had better be 0 at least. So then x will be equal to, solving this one, x equal to 1 over 3, okay? And then this one, x equal to minus 2, if you are to solve this thing. Setting this equal to 0, it will give you this thing. All right. And so next we have, so these are the x-intercepts. So that's that part of it, the answer, the x-intercept, something. Anyway, so the y-intercept is much easier because y-intercept just means, well, what is the y value when x equals 0? Now, if x is 0, then what's y? Y is 0, 0, in here, 0 and 0. So y equals to minus 2. The f of x equal to y. So y is minus 2, and that should be the y-intercept. So having said that, let's check. So the x-intercept is at 1/3 and minus 2. Oh yeah, the complete answer I should say that the x-intercept should give the whole point, which is at 1/3, comma 0, and minus 2, comma 0. The x-intercepts are always at something comma 0 because it has to be on the x-axis. So the y value has to be 0. The x-intercept should be 0 and 2, minus 2. I'm missing the minus. There. How's that? Yeah. When x is 0, y equals to negative 2. Okay? Yeah, see, that's one thing about math. It doesn't let you get away with screwing up. And other subjects, a lot of times you can say something completely stupid and everybody will tell you how wonderful you are, but not math. And anyway, so let's look at next. Let's look at the, what is that? More x-intercepts? Really? Right. Why am I doing more x-intercepts? Let me look at this. Okay, now let's look at example 8, which is a quadratic function, which is not going to be able to factor this quick way, okay, the easy way. There's no easy way to factor it. So your book wants you to write it to rewrite the formula in standard form, which is also called completing the square, which we've done earlier. So please do that part yourself, okay? In the meantime, I'm going to pull out the quadratic formula. So f of x is this thing, okay? So by the quadratic formula, x equals to minus 4, okay? B plus or minus square root of b squared, 4 squared, minus 4 times a is 2, times c is negative 4, and then all over 2 times 2. And that would be equal to minus 4 divided by, here's 4 down here, 4 squared, and that becomes a plus, okay? So that's let's see, plus or minus square root of 16. 16 times 2 is 32, which is equal to minus 4 plus or minus square root of, what is that? 16, that's 48. 48 is 4 times 12, right? Or no, 48 is 6 times 8, sorry. No, 6 times 8, what? No, it's, and now I can't factor 48 properly. Let me think. So 48 is 12 times 4. That's 4 squared times 3. Okay, that's better. 48 equals to 4 squared times 3. Okay, so then we equals to minus 4 plus or minus, we'll take 1 4 out. So we have square root of 3 left. And then divided by 4. Or minus 1 plus or minus square root of 3 divided by nothing, because we can cancel out the 4, all 3 of them. So it should be, so the x-intercept should be, yeah, minus 1 plus or minus square root of 3, okay? And then you add this comma 0 that to give you the actual coordinate of the x-intercept, which is officially minus 1 minus square root of 3 comma 0 and minus 1 plus square root of 3 comma 0. Well, please do it the way your book does, because your book wants you to pull out the h and k, which is okay. That is the way. In fact, that is the way to do it if you didn't know the quadratic formula. See, you don't have to have the quadratic formula to solve any quadratic equation. This is just, let's cut to the chase and get to the end.
Mark.
So next, let's look at example 9 on page 413, where we have a ball is being thrown in the sky and come back, and we'll assume that follows a parabola path, okay? And we'll simulate it, the parabola like this. Now that we have the equation, we will calculate what happens when does it hit the maximum. The t stands for time. All right, and so you start out here, t equal to 0. Okay, at some point, t has to become, t is getting to the top part of the parabola. So to find out when does it hit the maximum, we set this value right here. Okay, the vertex coordinate is minus b over 2a. So the maximum is when t equal to minus b over 2a. Okay, so t equal to minus b over 2a. So minus b is 80. Minus 80 divided by 2 times negative 16. Okay, the negative is very important. Okay, the parabola better be upside down. Otherwise, if it's like this, that means your ball will come down to the ground and shoot to infinity, which doesn't make any sense at all. So this is, you notice the 2 negative signs cancel out each other, so that equals to 5 over 2. So after 5 over 2, this is in seconds, I believe, then it has reached the maximum. So that's the first question. The second question, what is the maximum height? Then we'll plug this 5 over 2 in this thing, okay? That will give us the height at that point of time. So let's plug that in. Okay, all right. Okay, h of t equal to 16 times 5 over 2 is 2.5, okay, squared, plus 80 times 2.5, that's 5 over 2, and then plus 40. Okay, so there's not much to do now except to pull out the calculator and see what comes out of it. All right, so I plunged it into the calculator. This problem doesn't have a lot of tricks to it, I don't think. So maybe this is easier. So anyway, we have 16 times 2.5 squared. Okay, push the x squared button for that. And then plus 80 times 2.5 plus 40. And that should equal to something. 340 is what I got. 340. Nope. Why does the book get I forgot a negative sign again. Minus, see? Minus. You see, if I was teaching a real class, some student would have yelled out, hey, minus. But being that it's a video course, I'm left to make my own mistakes in quiet. Anyway, let me change it to minus. Okay, now I got 140, which is, according to the book, does the book say 140? Yes, it does. Okay, so k, the height is equal to 140, which is the highest point of where this thing reached, whatever we're throwing here. And then the next question is, when does the ball hit the ground? So then that would be equal to, when we set this thing to be 0, and No, we don't. No, we don't set it to be 0. Actually, because when this thing the height is equal to 0, then let me think about this for a second. Now I see what's bothering me. I didn't read the problem carefully. Okay, this ball isn't thrown from the ground. It's thrown from some tall spot. Okay, it's actually thrown from, what is it, a building? Yeah, it's actually thrown from a building. That's why when t equals to 0, this thing is not 0. Okay, so but however, when we don't care about that, but eventually it has to be 0 because this height is measured from the ground. So if we set this thing equal to 0, then whatever t that solves it, will that makes sense. It's gonna be the time when the ball hit the ground. So we're gonna do that. So this equation, let's write it down again. So h of t will become 0. Okay, and I'll copy this thing down. All right, so I set the equation to be 0. We need to solve for t. Okay, so to figure out where it reaches 0. Now to do that, let's clean this thing up a little bit. This is going to be 0. Okay, this is a nice problem in the sense that the author set up the problem so that easy for us to clean up. In real life, it's not going to be near as clean, and we're just going to do things the hard way. But right now, there's a way to clean it, so we'll take advantage of that. And so that becomes let's divide everything by 8 because there's a common factor here. Okay, so then we have 2t squared plus 10t plus 5. Okay, and that equals to 0. Well, it's right. Then I just do that so the numbers are a little smaller and it's easier for me. It might or might not be worth it. We'll see. Okay, and so now let's solve this thing. Does this thing even solve nicely? I don't know. Let's check. No, it does not. Okay, so we're gonna pull out the quadratic equation, which is yeah. Did I forget something again? Yeah, the minus sign. Ugh. Why do I always forget the minus sign? I think I just like positive stuff. Okay, but anyways, here's this thing, and let's pull out the quadratic equation. Quadratic equation says t equals to minus 10. Okay, plus or minus. Let's get a b squared, 10 squared, minus 4 times minus 2 times 5. Okay, all right, so that's so far so good. And then divided by 2a. 2 times, what's a? A is minus 2. Now the minus sign is critical, okay? Because, well, then eventually we get, so then t equals to minus t divided minus t. Let's look at the minus version first. Minus t minus square root of whatever this is. Okay, that's 100 minus 4. That becomes a plus, all right? So plus 40. 100 plus 40, right? Yeah, I think so. And divided by, this is a plus or minus situation. I guess we'll write it down that way. Divided by minus 4. Okay, and don't forget the minus sign here. Okay, that's better. So t equals to, we'll do the negative one first because it cancels out with the negative sign down here. It becomes 10 plus square root of 140 divided by 4. Okay, and that's one solution. Or t equal to 10 minus square root of 140 divided by 4. That's the root on the other side, and we don't care about that. Okay, I mean, that does nothing. So we'll take only the root that is the biggest root. See, because if you have 10 minus something, that's less than 10 or whatever dividing. So we'll take the bigger number because that's the one we're looking for. So focusing on this one, that equals to something. Let's calculate it out with a calculator. Okay. All right, so I push it into the calculator, and it says that it equals to 5.458, which according to the book is what the book says, okay? And as we mentioned, the other time doesn't matter because that's the before, and we don't care about before. We only want to know when it hits the ground later. But the point, however, in this point, I want you to pay careful attention as to how this is done. Okay, now you notice that I put parentheses in here, even though there are no parentheses here, because you're dividing the whole thing by 4, you absolutely must put parentheses in because there's a plus sign. Okay, if you don't, then if you just type it in without parentheses, you will get the wrong answer, and you wouldn't even know why that is. And that's what I mean by sometimes math students can't use the calculator because they ignore the rules. The rule says that if you punch something like this into a calculator, you better put parentheses in it, even though you don't need to do that when you're writing it down. Now, so I'm going to show you exactly how this is done. Okay, I will. Let's see. All right, I will type this in backwards, which will take a while, so please bear with me, but this is important, okay, that you know exactly how to type in certain things. That is more tricky, or maybe not so much tricky as, I don't know, just students tend to have trouble with this kind of thing. I don't know why. Anyway, so 1, 0, okay, 10, and then plus, so don't forget the parentheses, right, plus square root. Where's the square root? It's up here somewhere. I think it's this thing. Okay, square root of 140, that's fine, 140. Now at this point you're still in the square root, okay, and you have to get out of there. To get out, in my calculator you push this button. And your calculator might be something different. Whatever it is, you need to get out of the square root because then it will continue to type inside the square root. So once you get out of the square root, then we type close parentheses. Okay, because that's the end of the thing. And then the whole thing will be divided by, okay, the division line is divided by 4. And if you type it in like that, then the answer will be correct. Now my calculator is on the, what is this, fraction or something? Yeah, there's a button that will change it to decimal. See? And that is how you get this stuff done. So be very careful when you use the calculator. Okay, the calculator is very smart and doesn't ever make mistakes. But if you make the mistake of forgetting the parentheses, then you're going to be dead in the water and don't even know why. So pay careful attention, and that is the time, and that should be the end of this section. Now for homework in this section. There it is, right, on page 415, please do problems 7, 11, 15, 19, 23, 27, 31, 35, 39, 41, 45, 49, 51, 53, 57, 61, 65, 67, 69, 71, and 75. And when you're done, come back and I want to talk about some of them. So for homework, let's talk about problem 31 on page 415, where we have some equation where the vertex is at 3 and 2, okay, and then it goes through some point that's called 10, 1, and so we are just going to write that down. So the function is then y equal to let's see, okay, following this formula right here. All right, y equal to a. Let's not forget our a. And then x minus h is 3, x minus 3, okay, and squared, plus k is equal to 2. And that is our general form, which is good, except that we haven't figured out what a is yet. And that's where this 10, 1 thing comes in handy, which says that when x is 10, y will be equal to 1. So therefore, we'll write down 1 here, okay, equal to a times 10 minus 3, that will be 7, squared, plus 2, okay? So that gives us a equal to, let's put, I guess I won't write it like this. So we have a equals to, put the 2 on the other side, that will become, I'll write it right here, so that everything is lined up, okay? Now 1 minus 2, that's minus 1 on this side, my marker there. Okay, minus 1, and then here's a divided by 49. Okay, and that is the answer of a, which means the equation then is minus 1 over 49 times all this stuff. But the book wants us to multiply this thing out. Okay, they don't want it with this form. they like the normal form, which is just something x squared plus something x, then plus some number. So that is ax squared plus bx plus c, that thing. So we just have to multiply this out, which is, unfortunately, this is not a nice looking number. So we're stuck with something that is not very beautiful, which is okay. All right, so a is negative 1 over 49. Let's, let me see, how will I, well, anyway. So there's no getting out of it. So minus 1 over 49, okay? Then it becomes a times x is x squared, right? So far so good. And then a times, so that becomes minus 6. Minus 6 divided by plus 49, because this minus 3 plus minus 3 is minus 6. But then a is negative, so it becomes a plus, okay, for the x. And then finally, plus 9 divided by the negative 1 over 49, okay? And then plus 2. So this part looks okay, is more or less correct. This part, however, we need to add this stuff up, which becomes this, is this a minus 9? Why do I have 9 here? Yeah, yes, because 3 times 3 is 9, okay? And so then altogether it becomes, let me pull out my calculator. All right, so I got minus 9 divided by 49 plus 2, okay? And let's see, and yeah, okay, I should be able to see it okay. And it equals to 89 over 49, what a lovely number. That is, turns out to be the right answer, okay? That's 89 over 49. So this less than pleasant looking quadratic equation actually is the right answer. So that is problem 31. So next, let's do problem 45, where we see the graph right here. Okay, what is this equation? So we see the vertex, and so we'll write down the equation based on the vertex, following this formula right here. Then f of x or y, let's say f of x, I guess. F of x is okay, equals to, so f of x equals to, give me a second here, I need to change my marker, so as to not confuse with the green stuff on the other side. Okay, so f of x equals to a. All right, we don't know what a is yet. X minus h. What's h? H is minus 2. So x minus minus 2. Okay, squared plus k is, k looks to me like positive 3. All right, so we'll just figure that's correct. Now that is the equation, but we still need to figure something out. And that is, we need a point. Pick some point that's convenient. I choose the point x equal to 0, okay? And when x is 0, y is 2. All right, so let's pick a nice convenient point. So minus minus just means plus, okay? So then this, we'll pick 0 and 2 to figure out what a is. So if it's 0 and 2, then plugging in everything. So f of x is y, which is 2, equals to a times 2x plus x is 0, okay? That's 2 squared is 4, plus 3. So that gives us, so 4a equals to minus 1, okay? Move the 3 over here, becomes negative. It becomes minus 1. And then a will be equal to minus 1 over 4. So the entire equation is equal to, is y or f of x equal to minus 1 over 4, that's a, times x plus 2 squared, and that plus 3, and that should be the function. Now, the book, of course, wants us to do a little more work and give us the other equation, which I guess is not, won't take too much, because it's, the numbers are here not so, so not too bad, I guess. I wish it wasn't a fraction, but, and anyway, so this is minus x squared over 4, that's the first term, okay? And then minus just x, all right? And then minus 1 plus 3, so that should become a plus 2. So that should be the answer. Yep, that is correct. This is the answer at the back of the book, okay? So that is the end of whatever this problem is, 45. All right, and let me clean off the board. Next, let's look at problem 67, where we have somebody building a dog park. Okay, again, they start with 300 feet of fencing, and that's all they care about is getting the most out of their fencing and not the land itself. Okay, so let's do that. So the dog part is done in an interesting way. So we have two sections, okay? And then we have, so the fencing works like this. We have three identical widths. These are fence, okay? And each one we will call it X. So we have 3 X's worth of fence just doing this part. And the rest of the fencing, we will divide it in half, right? Subtracted 300 minus 3x, that's what's left, and we divide it by half to do the top, the length, and the bottom length. So together that makes 300 feet worth of fencing, have this whole thing fenced up. Therefore, the area of this thing is, the total area of the dog park is then length times width, which is equal to x times 300 minus 3x divided by 2. Okay, so that is our entire area. We'll call it A. Okay, that's A, and we need to maximize this value. In other words, this thing is upside down parabola, and then the question is, what is the value at the highest point? So we want to maximize the area. All right. So having said that, then we do what we've been doing this whole time, okay? So then let's multiply this thing out. So area equals to, multiplying it out, we got minus 3 over 2 x squared, okay? And then plus 150x, right? All right. So then what is the highest point though? The highest point is where x equal to value of h, which is highest point is x equal to minus b over 2a, okay? Minus b over 2a, which is, in this case, minus 150, that's b. 2a is this value here, 2 times 3/2. And don't forget the negative sign. There. All right, so yeah, I can see that's a negative sign. Anyway, so the negative signs cancel out, okay? So that's good. And then, so our x will be some value. We'll write it right here. X is going to be, let's see, 50, I believe. Because the 2 cancels out with the 3 over 2. Okay, this is a division happening. So you can, this is at the bottom. I just wrote it slanted. But it's actually, you can imagine it at the bottom. So 2 cancels out this. And then 150 divided by 3 is 50. So x should be 50 when the maximum take place. Now, if x is 50, what is the area? Area then equal to area, what are we asking for? Let me see. Find the dimensions. We don't care what the area is. We just want the dimensions. Fine. So x equal to 50. Forget the area. And this is 50, and this thing is 300 minus 3 times 50. Okay, so that the length then is 300 minus 3 times 50, which is 150 divided by 2, and that gives us 75. So the dimensions should be 50 times 75. And that is problem 67, so let me check. Yep, that is correct. All right, okay. So the next problem, problem 75. All right, problem 75, we're going to use this trick, just like one of the examples, okay, where we pull this thing out. So let's look at this. It's a farmer says that if we have 75 trees, okay, this is the trees, okay, and then each tree will produce 20 bushels, all right. So we'll write that relationship down. And then it says that for each additional tree planted, let's say she planted 76 trees, okay, and then the yield will decrease by 3 bushels. So then she'll only get 17 bushels if she planted, say, 76 trees. So she only get the down by 3 bushels. All right. So what is the relationship of tree and bushel yield? So we are going to pull this trick in order to find out. First, let's find out what is m. Okay, m is equal to, let's call it this we'll call it y2, okay? 20 minus 17 divided by 75 minus 76. So m equals to minus 3, all right? So it is going down by 3 bushels per tree planted, okay? So that makes sense. Now, having said that, then so then we come up with the equation for this linear relationship. Then y equals to, what is the equation? Then y, which stands for bushels, okay? So y minus y1, we'll pick, I don't know, 20 is good. It doesn't matter which one you pick, you'll come up with the same answer. Equal to minus 3, okay, m, following this equation here, times x minus x1. So we pick 20 here, so we'll pick this x. Yeah, doesn't matter which one you pick as y1, x1, as long as you're consistent. If we pick this 20 as y1, then we better pick this one as x1, okay, to make sense. And then, so here's the equation, which we will clean it out a little bit. So y stands for the bushel, okay? Y equal to minus 3x, okay, plus 3 times 75, we'll multiply that later, 3 times 75, and then plus 20. Okay, which is 3 times 75 is 225 plus 20. That makes it 245, I believe. So we'll write that down for now. Okay, so let's say, well, I'll double check the numbers later to make sure I didn't mess up on the multiplication. So anyways, let's say this is it. Okay, y equal to that thing. Then y stands for the bushels, okay, and x stands for the trees, number of trees. And then now we are going to, what do we want? We want to figure out how many trees to plant to maximize the harvest. That is, we need to maximize trees times bushels, right? Which is, we need to maximize y times x times y. So the maximize, the function that we're calculating, that is the total yield. The yield then, okay, or the harvest will be trees times bushels, okay? So will be x, which stands for, well, this is y, right? Yeah, this is y and this is x. So I should write it here. So x is the trees and y is the bushels, okay? And so x times x, which is trees, times y, which is this stuff, minus 3x plus 245. And we need to maximize. This is equal to the total yield or harvest or something. What do we call this? I guess we'll call it H for harvest. So we need to maximize H, okay? So let's, which means we're going to do this again, okay? We've been doing this most of the time. And so this equal to, let's write out the equation. That's minus 3x squared plus 245x. And to find out, so this is a parabola, again, upside down, which is important because then you have a maximum point, right? Because you know there's a maximum point to how much she can grow. She can just increase the number of trees and go to infinity in terms of profit. That's just not going to happen, okay? So there is a top point. So the negative sign is very important. And with that, we have it. So now that we have that, let's follow this formula right here. We have, and we need to find out what minus b over 2a is and then plug it in to find the other thing. We can even memorize the formula for k, which is possible, but the formula for k is too complicated. We'll just do this. It's easier, okay? So minus b over 2a is equal to, let's write that down, or h equal to minus b minus 245 divided by 2 times minus 3, and that equals to some value. And then once we find that out, then we'll plug it into here to calculate the entire value. So we will, minus b divided by 2 times a. Yeah, I think I got it right. And h is positive, okay? So by the time we're done, which makes sense. Why would it be negative? So then, so a, being that h stands for x, which is the number of trees. So having figured out what h is, then we will plug it in here. Well, H, yeah, H is in this case not a whole number, but that's okay. We're just sort of approximating, okay? And so then this equal to, let me check. Actually, the book only wants to know how many trees we plant. In other words, what is age? Okay, we don't even care what the maximum profit is, so we don't have to go that far. This is it. This is the answer, and this add up to be about 2,245 divided by 6. That is equal to 40, about 41, right? If it was 246. Yeah, if it was 246, that'd be better yet. But it's only 245, but it's close enough. It's just trees. So if she plants 41 trees, then the whole thing should come out nicely. That she should maximize her profit, which we are not required to figure out what it might be. So that marks the end of this section.